Welcome to School of Advanced Chemistry. I'm Khizar. I'm going to explain how to make a chemical formula. How to make an empirical formula, how to make a molecular formula, what is meant by a chemical formula. Let's talk about it. Formula is basically the representation of type and ratio of the different elements in a compound. Type and the ratio of different elements in a compound is said to be its formula. So formula is the exhibition, presentation, and notation of the different type of element and ratio of the element. For example, NaCl is the formula of sodium chloride. NaCl, there are the two elements, one is sodium and the next one is Cl. H2O is the chemical formula of water. H2O. Two type of elements are there, but the ratio is 2:1. 2 hydrogen ratio 1 oxygen. H3PO4, that is phosphoric acid, a covalent molecule. And here you can see three different elements are over here. Hydrogen, phosphorus, oxygen. And the ratio is 3:1. You can write 1 over here. And 4. 3:1:4 ratio of these element is lying in this formula. S8, that is a sulfur, that is again a simple covalent molecule. It is having the same type of element, 8, but all these 8 are sulfur. Next one is silicon dioxide. It's a macromolecule. And here are basically two elements, two type of elements are there, silicon and oxygen, and the ratio is 1:2. So basically a chemical formula is the presentation of type and ratio of different elements in a compound. The compound may be an ionic compound or compound may be the covalent compound. There are further two types of a chemical formula. One is said to be molecular formula. What do you mean by the molecular formula? Actual whole number ratio of the element in a compound. Exhibition of actual whole number ratio of the element in a compound is called its molecular formula. For example, in case of glucose, C6H12O6. C6 overall, the elements carbon, C, hydrogen and oxygen. Three different elements are lying over here. And the ratio is 6:12:6. Complete ratio. Actual ratio of elements in one molecule. Actual ratio of different atoms, you can say, in one molecule is said to be its molecular formula. Formula that is showing the molecular arrangement, molecular composition is said to be the molecular formula. The next one formula is basically that is said to be empirical formula. Empirical formula shows the simplest whole number ratio, not the actual one. It is showing the simplest whole number ratio of the atoms, or you can write the simplest whole number ratio of the element in a compound. That is said to be empirical or the simplest formula. For example, CH2O is the empirical formula of glucose. 1H2O1. It is the simplest formula of glucose. However, the empirical formula is not very much worthy, you can say, because on behalf of empirical formula, we cannot check the actual identity of the molecule. For example, this CH2O is the empirical formula of glucose as well as ethanoic acid. So, simplest formula of the glucose is CH2O, and similarly the simplest formula of ethanoic acid is also CH2O. So on behalf of an empirical formula, on behalf of the simplest formula, we cannot recognize the actual composition, or we cannot recognize the actual identity of the compound. For example, I'm going to write it C2, here are 2 carbons. How many hydrogens are there? 4 hydrogen and 2 oxygen. So this is the molecular formula. And in both cases, in this case as well as in case of glucose, we are having the same answer of empirical formula. So empirical formula is not the authentic formula. However, it's going to tell us the ratio of the element in a compound or the percentage of the mass of the element in a compound. So it is basically used to check the percentage composition, to check the percentage of mass of different element in a compound, and so on. Empirical formula can be calculated by three ways or using three options. Number one, from mass percentage composition of the elements, hydrogen, carbon, oxygen, nitrogen, etc. So from the mass percentage composition, we can calculate the empirical formula. The next one way out is we can find the empirical formula, we can calculate the empirical formula from reacting masses of the reactant. For example, we are having, let's suppose 12 gram carbon was allowed to react with, let's suppose 40 gram hydrogen, and let's see what should be the empirical formula. Yes, we can find the empirical formula in this way. Number one, from the percentage of mass of each element present in the compound. The next one, the masses, reacting masses of the element can also be used to calculate the empirical formula. The last one, the simplest one is this one, from molecular formula. If you're having a molecular formula, then you can simplify that formula, and its simplest form, its simplest shape is said to be empirical formula. Let's see how can we calculate the empirical formula by these three options. Steps to calculate the empirical formula from the percentage data or reacting masses data. Step number one, divide mass percentage of an element by AR, or divide the mass of an element by AR. So this is quite pretty similar method. If you're having the percentage data, or if you are having the reacting masses data, then you will divide these data by the relevant AR of the element. What is the next step? Then you will get the simplest answer, the lowest answer. Find the simplest ratio by dividing the lowest answer. After division, when you are going to have the answers 2, 3, 4, 5, then you will again find the simplest ratio of these answer by division of that's the lowest answer. And now you are having the simplest ratio between the elements of their masses. Make empirical formula using these simplest ratio. Make empirical formula using this simplest ratio. If unfortunately you are not having the whole number, if you are having the fractions, then change to the whole number ratio, but don't round it off. You can change the fraction into whole numbers by other way, by multiplication. However, you can round off up to 0.1% difference. For example, 2.1 can be written as, or that is equal to 2, and 2.9 can be written as 3. But beyond the difference, if the difference is beyond the 0.1, so you cannot or you shouldn't round it off. Let's see, here is an example how to calculate the empirical formula. Compound having 81.81% carbon and 18.19% hydrogen. Find its empirical formula. We know that the percentage of the carbon versus a ratio and percentage of the hydrogen. 81.81%, it is 18.19%. It's divided by AR, and AR of the carbon, you can check it from the data booklet, that is AR of the carbon is equal to 12, ratio divided by the AR of hydrogen, that is equal to 1. So this answer is equal to 18.19, that is equal to 6.817, you can say. Now the next step, or step 2, is divide 6.817 on both sides because it is the smallest or the lowest answer. 6.817 on both sides. So this side will be equal to 1. And what is the answer on the next side? 2.6. 2.6. Now you can see this 2.6 cannot be rounded off. So I'm going to change into whole number by a multiplication of 3. So I'm multiplying 3 on both sides, multiplying 3 on both sides. So the ratio will be equal to 3:8. So the answer is C3H8. The empirical formula of this compound, this molecule, is C3H8. So from the percentage composition, directly we can find the empirical formula. We are not sure about it. It may be the molecular formula as well. But from the percentage data, the first answer that is coming from the percentage composition or from the reacting masses will be empirical formula. That will not be necessarily a molecular formula. It is true. It is always true that it will be an empirical formula. We can make empirical formula from molecular formula. So how to make empirical formula from molecular formula? It's quite simple once again. For example, we are having a glucose C6H12O6 once again. This time I'm going to check the common mole of the element. So the common mole number you can say of the element, the highest common number, that is equal to 6. So I'm dividing 6 on all these answers, on all these numbers. 6 ones are 6, 6 2, 6 ones are. So its empirical formula is CH2O. CH2O is the empirical formula of this glucose, as I have told you in my previous slide. So this 6 is basically the common mole of all these atoms. It is represented by N. It is represented by N. Here N is equal to 6. So this is the simplest way to change molecular formula into empirical formula. However, sometimes we cannot change molecular formula into empirical formula. For example, I'm having C3 and H8. It's a propane. It's an organic molecule, that is propane. Its molecular formula is C3H8 and it cannot be further simplified. Its empirical formula will also remain same. So yes, it's possible many of the organic compounds are having the same molecular formula as that of same empirical formula. I mean, they cannot be further simplified. So you can also say that they are not having any different empirical formula, or they are not having any empirical formula. Their ratio cannot be further simplified. So they are having just only molecular formula. Same is the case in case of ionic compound. For example, I'm having ionic compound, that is Al2O3. This formula is said to be a formula unit. So in case of ionic compound, the formula is said to be formula unit, and it cannot be simplified. So the formula unit is already an empirical formula, you can say. Again, you can see in any other example. For example, I am going to write it over here, Fe2O3. Again, it's an ionic compound and its formula cannot be further simplified. So in case of ionic compound, you cannot make empirical formula because that formula is already having the simplest common whole number ratios. So it is having only one nominee, that is said to be formula unit. Now, how to calculate, how to make, how to find molecular formula. For molecular formula, there are three way out, you can say. Number one, we can change structure formula into molecular formula. We can use empirical formula to make molecular formula. And we can change, or if we are having the value of MR, then we can make empirical formula from the value of MR. From the value of MR, that is a very much important tool, very good tool to convert or to calculate the molecular formula of the covalent compound, especially from MR. For example, if I'm having the structure formula, or you can say the displayed formula, then we can change this displayed formula into molecular formula. In this case, how many carbons are there? 1, 2, 3, and 4. So 4 carbons are there. Then I'm going to write the nitrogen because the next higher valency goes to nitrogen. There is only one nitrogen. I'm putting N over here. Then I am going to write about oxygen. The next valency goes to oxygen, that is equal to 2. So the number of oxygen is equal to 1. The last one is the hydrogen. 3 plus 3 plus 1, that is equal to 7. H7. So this is the molecular formula of this organic molecule. This is displayed formula. It is called structure formula. It is called displayed formula. And we can change displayed formula to molecular formula. Let's see the next one. How can we change empirical formula into molecular formula? Here you will have to remember a simple relationship. I mean, in this case, molecular formula is equal to empirical formula multiplied by N. N, as I have told you, it's a common number of moles. It may be 1, 2, 3, 4, and etc. Highest common number of element in molecular formula, or the highest common mole, number of mole. Now the next one formula is the second formula. In this case, in this way, you can find the value of N. So whenever you are going to convert empirical formula into molecular formula, then you will have to know the value of N. And so if you want to calculate the value of N, you should know the value of MR or the formula mass. If you are having the value of MR, then, and if you are having the empirical formula, then you can calculate the value of N. For example, let's see in this example. Empirical formula is equal to HO, H1O1. Its MR, its molecular mass of its molecular formula. I mean, its molecular formula is having the mass that is equal to 34. So how to make, or what will be its molecular formula? I'm going to find the N. N is equal to MR. MR is equal to 34. Divided by empirical formula mass. What is the empirical formula? That is HO. The empirical formula mass is equal to 34 divided by 1 plus 16, I mean 17. So answer is equal to 2. So N is equal to 2 in this case, and now we can change empirical formula by multiplying 2 in its subscript, and it will be equal to H2O2. So this is the molecular formula. Empirical formula can be changed by multiplying N into molecular formula. Again, it's the simplest one. We can change MR into molecular formula. For example, I'm having the simplest example over here. If the phosphorus, a molecule of phosphorus that is having MR 1, 2, 4. Phosphorus is an element and is having simple molecular formula or simple molecular structure, and its MR is equal to 124. Then what will be its overall molecular formula? In this case, you can write AR again multiplied by N is equal to MR, right? So MR is equal to 124. AR, you can check it from the data booklet, that is 31 in case of phosphorus. Multiply by N, and answer should be 124. In this case, N is equal to 124 over 31, and the answer is equal to 4. So phosphorus into number of mole, phosphorus into number of mole, that is equal to 4. So this is called molecular formula of normal phosphorus. Now come towards the different problems. Let's solve the different questions regarding the empirical formula and molecular formula. A compound containing only the element carbon and hydrogen. It has 80% by mass of carbon. What is its empirical formula? It's quite simple. Carbon ratio hydrogen. The percentage of carbon is equal to 80%. The hydrogen, only two elements are lying in the compound, then obviously hydrogen will be equal to 20%. Carbon divided by its AR, that is equal to 12. Hydrogen divided by its AR, that is equal to 1. So it will be equal to 20, and 80 divided by 12, the answer is 6.66. As you know, it's the smallest and the lowest answer. 20 divided by 6.66, and the answer is equal to 3. Its answer is equal to 1. Its answer is equal to 3. So 1:3, C1H3B is the correct option. The next question, what is the empirical formula of a compound containing 12 gram carbon, 2 gram hydrogen and 16 gram oxygen only? If a compound that is having 12 gram carbon, 2 gram hydrogen and 16 gram oxygen, carbon versus hydrogen versus oxygen. Its mass is equal to 12. Given mass is equal to 12, its given mass is equal to 2 gram, its given mass is equal to 16 gram. So this 12 divided by AR of carbon, that is also 12, 2 divided by 1 AR of hydrogen, 16 divided by 16, that is the AR of oxygen. So the answer is 1:2:1, and CH2O and CH2O. C is the correct option. An element E forms a hydride EH4 which contain 90% by mass of E, 90% mass of E. If the relative atomic mass of hydrogen is equal to 1, number one, the formula is given over here. It's a little bit tricky question, and I'm going to tell you a Khizar rule or Khizar's method, you can say. Formula is given, percentage of one element E is given, AR is obviously hydrogen, that is equal to 1 is given. What is relative atomic mass of E? What is relative atomic mass of E? So I am going to write the similar step. E ratio hydrogen. E ratio hydrogen. The percentage by mass of E is equal to 90%, and hydrogen will be obviously 10%. 90 divided by AR, that is yet unknown, and the AR of hydrogen is equal to 1. I am putting 1 over here. The next thing you can see from this formula, 1E and 4 hydrogen. The ratio between E and hydrogen is 1:4. So I am putting 1:4. The next thing is I am marking equal over here. Let's pause. Now the next one, the basic rule is, now I am going to cross multiply or applying the cross multiplication over here. So after the cross multiplication, 4 into 90 over AR is equal to 10, or you can write as 4 into 90 is equal to 10 into AR when we switch this AR towards right hand side. And There's the cancellation of zeros. So AR finally, that is equal to 36. So actually the AR, relative atomic mass of V, AR is equal to 36, and B is the correct option. B is the correct option. What is empirical formula of ethanoic acid? So once again, you should write first the displayed formula of ethanoic acid, as far as if you are the student of O-level chemistry. Then you will change it into molecular formula or the condensed formula. I mean, C2 carbons are over here. C2, how many hydrogens are over here? 1, 2, 3, 4 hydrogens are over here. 2 oxygens are over here. Now I'm going to simplify it. Divide by 2, divide by 2, divide by 2. The highest common mole of the element of the atom is equal to 2. So the answer is CH2O, CH2O, CH2O. A is the correct option. The next question is, use of the data booklet is relevant to this question. In lead petrol, there is an additive composed up of lead, carbon and hydrogen. This compound contains 29.7% carbon, 6.19% hydrogen by mass. What is the value of X in the empirical formula PbC8H? You can see in the formula the value of Pb is equal to 1, the value or the ratio of the carbon is equal to 8, and the value or the ratio of the hydrogen is equal to X. So we are supposed to find the answer of the X. I am going to apply the similar rules, but this time I'm not, including lead into this computation. I'm simply making the formula between hydrogen and carbon. The percentage of the carbon is equal to 29.7%. and the percentage of the hydrogen is equal to 6.19%. This carbon percentage divided by its AR is equal to 12, and this 6.19 divided by 1, that is the AR of hydrogen. Okay, now what is the answer of this carbon, the ratio of the carbons? 29.7 divided by 12. That is equal to 2.475, and 6.19 is the answer of ratio of hydrogen. Now divide by 2.475 on both sides, as it is the smallest number. That is equal to 1. And what will be the answer? 6.19 divided by 2.475, and the answer is 2.5, and the answer is 2.5. So the ratio of the carbon and hydrogen, the simplest ratio is 1:2.5, you can say. If carbon is equal to 1, then hydrogen is equal to 2.5, but we are entitled to make the answer with respect to 8 carbons. So if the carbon is equal to 8, then hydrogen will be 2.5 into 8. So answer is 20. C8 and H20. So D is the correct option. This X is equal to 20. That's all about today. Thank you very much. Have a nice day. Please subscribe my channel, hit the bell icon and share it with your friend. Thank you.